Hello and welcome everyone to lecture number 6 of alcohols, phenols and ethers. See, what I do is first I'll discuss maximum of the theory. Once I complete the alcohols and phenols, then I'll do some one more lecture just on solving of the example. That will give you a more boost to the learning. Okay, so we'll few reactions are remaining of the alcohols, phenols. We'll do that and then we'll take a solving on it. Solving. We'll take examples in that case. So first here reaction of the lecture 4 is esterification of the alcohol. Esterification of alcohol. What is the meaning of this esterification of the alcohol? Alcohol is converted converted to ester. Reaction mechanism is very simple. Remember, nothing is as simple as this. Okay. Esterification of the alcohol is the topic and the reaction mechanisms is very simple. So we'll take a alcohol. We'll take a alcohol this way. ROH. This is a lone pair of electron on the oxygen. Two lone pairs are there on oxygen, right? And you take a carboxylic acid. You take a carboxylic acid, RCOOH, right? So this is alcohol and this is carboxylic acid. So here the product what you are going to get is RC. We'll put this as a R dash just to make a difference between R of this and other of this. So this is ROOR dash plus water. Like this is the ester what you are getting. Means reaction of the alcohol with a carboxylic acid. This comes under what we are doing. Actually, we are learning the chemical properties. No, this comes under everything. Whatever we learned, acidic properties of the alcohol. That is what chemical properties of the alcohol. So here you can write this heading is chemical reactions or the properties, chemical reactions of alcohol. How this alcohol is reacting with a carboxylic acid. That is what we are learning. So we'll look into the mechanism. Mechanism is very simple. So what is the basic term I use most of the time? It is electron rich to electron deficient mechanism, right? So this is the basic thing which will happen in every mechanism. So this is the alcohol. This is the alcohol. These are the lone pair. Lone pair means electron rich, easily available for the donation. This is R C double bond O OH. This is a lone pair of electron which is going to go and attack on this carbon. Why only this carbon? Why not other carbon? Why not carbon of this R group? The reason is that this carbon is the electron deficient. This carbon is electron deficient because it is connected to two oxygen. So this carbon is also called as electrophilic center. Electrophilic center means electron deficient center. Electrophilic center, right? So here this is going to happen. Rich will attack deficient. The weakest bond is going to break. Which is the weakest bond? It is a pi bond which is first going to break, right? The product what you are going to get is R dash C O O minus. Why? This pi bond has converted to that. And here this is O, this is H, and this is that R. This whole part is getting connected, and this is having a positive charge over here because oxygen has donated an electron over there, right? Oxygen has donated its electron to form a new bond over there. So that's why oxygen is having a positive charge, and this is O minus. Always remember that having a positive charge on the electronegative element is unstable. Positive charge, note positive charge on electronegative element. Electronegative element is unstable, very unstable. So oxygen is electronegative and the positive charge is there. So what will happen? I'll show this. So pi bond will again, where it will move, this is electron deficient carbon. No, so this electron will shift over here. This will break. This is the weakest bond, carbon oxygen. Why not this carbon oxygen bond is breaking? See, this is breaking means what? We are going to get back this, right? Which is not thermodynamically favored, right? So that is what the OH is going to form. And also, this hydrogen is going to donate its electron to this, right? And this will go as a H plus, and this is OH minus. So finally, what remains in the reaction is this. What remains in the reaction is this: R dash C double bond O R, sorry, yeah, O R over here, plus this OH minus and this H plus forms water. So this is the ester. This is the ester. Means if we take ethanol and if we react it with propanoic acid, if we react that with a propanoic acid, what will be the thing which will happen? This will attack over here. This bond will go, then back bond, and this will break, and this H plus will combine, right? So finally, in one step, I am going to show you this, what is happening, what kind of ester, CH3, CH2, C, double bond O, then O, CH2, CH3, right? This is the product, this is the product what you are going to get over here. So name of this compound will be what? It is this we name first. We'll call this to be a ethanol. What is this? It is ethanol, propane, three carbon system, OAT. It is a spacing. It is a spacing over here. So this is the ester what you are going to get if you react that with a alcohol. Carboxylic acid, I mean. And this is true for this also. Instead of R, you can also replace this with instead of R, it could be a aromatic, a benzene ring also. Okay, it could be aromatic, a benzene ring also. This is also possible. Now, what will be a reaction of a alcohol? What will be a reaction of the alcohol with acetic anhydride? Acetic anhydride is this: CH3, C double bond O, C double bond O, CH3. So write the heading. I did not write the heading. So reaction of alcohol, reaction of alcohol with acetic anhydride. So this is acetic anhydride. This is acetic anhydride. This is what? Alcohol. See, acetic anhydride, don't worry. Many students, many times, what happens, they get confused how to write the structure of acetic anhydride. See, I know many of the students will be knowing the structure of acetic acid. Acetic acid is this. How to get acetic anhydride? This is acetic acid, right? CH3COOH. You take 2 units of like this, 2 units like this, 2 units of acetic acid, and remove what? Remove water molecule. Remove water molecule and connect them. This is just a trick I am showing you how to remember acetic anhydride. What you are going to get? CH3, C double bond O, CO, CH3. This is acetic anhydride. If you want anhydride of any carboxylic acid, you need to do this only. Okay. So this is acetic anhydride. How the things, what would be a product over here? What would be a product over here? Can you guess the product? What would be a byproduct over here? This is electron rich. This is electron rich, right? Where it will attack electron deficient carbon. Whether this or this carbon, it is one and same. This bond will break, then it will back bond, and this will break later, right? So what you get over here is I'll take this to be, because I have taken acetic anhydride. Okay, let's keep this way only. Compound, what you are going to get over here is CH3, CO, OR. This hydrogen will combine with this O minus. So this is OH, C double bond O, CH3. So what you get over here, it is a ester. And other is what? CH3COH. It is acetic acid, a carboxylic acid, acetic acid. So here also you are going to get a ester for that, right? Reaction of the alcohol with acetic anhydride. Next, we'll do reaction of alcohol. Next, we'll do reaction of alcohol with acid chloride, with acid halide. Acid halide means what? Sometimes we say acyl halide also. This is also called as this is also called as acyl halide. Okay. X is a halogen. So you take alcohol. See, this is true for alcohol and phenol also. Huh? This is like R, I can write aromatic also, like benzene also. This is true for alcohol and phenol also. I'll not do separately for phenol. Just make a note. This is true for this. Like this is the case. I'll put this R dash. What will happen over here? What would be a product in the presence of pyridine? Remember this reagent. This is pyridine. It is R dash C double bond O OR plus HCl. Right? This is a ester, and this is hydrochloric acid. Right? So this is the thing. Next over here is a reaction with hydrogen halide. Next is a reaction with hydrogen halide. Next chemical property is reaction with hydrogen halide. What is the meaning of hydrogen halide? Hydrogen halides are this. Halides are this. HCl, HBr, HI. All these are hydrogen halide. HF is also a hydrogen halide. Okay. So we are going to do reaction of what? Reaction of alcohol. Reaction of alcohol. Okay, this is the topic with hydrogen halide. I'll write the reaction first. This is alcohol. This is HCl, and this is ZnCl2. What you get is a RCl plus H2O. This is the reaction we have done in haloalkane haloarine also. There we are learning this reaction as the preparation of the alkyl halide. Here we are learning the chemical property of the alcohol. So what is this? This reaction, I'll make some highlights of this. The first thing is that HCl plus ZnCl2, this is known as a Lucas reagent. This is known as a Lucas reagent. Okay, second, Lucas test is for this is also known as a Lucas test. This is also known as Lucas test. Lucas test, Lucas test is for detection of primary, secondary, and tertiary alcohol. So how we are getting that? The thing is that like this compound, what we are getting over here, the compound what we are getting, that is R halide. This is turbid in nature. Turbid. This is this is turbid in nature, right? This is transparent. This is transparent. You add HCl. So what will happen? Whether the reaction is happening. So obviously this reaction will happen, but different alcohol will take different time. You know. So if it is a tertiary alcohol, if it is a tertiary alcohol, what will happen is that it is a tertiary alcohol, instant turbidity you will get. Instant turbidity means there is a formation of RCl, that is this product very fast. Instant turbidity. If it is a secondary alcohol, if it is a secondary alcohol or secondary alcohol, turbidity will take place after 5 minutes. Okay, turbidity is after. Turbidity tells about the formation of this product, alcohol. Turbidity is after 5 minutes. And if it is a primary alcohol, then the turbidity is very slow. Turbidity is after, turbidity is after 30 minutes. Now, why this is so? Why this is so? We'll understand the reason of this. Why tertiary alcohol gives a fast turbidity than secondary, and secondary gives fast turbidity than primary. See, if it is a tertiary alcohol, you react alcohol with first of all this reaction, this reaction goes via formation of carbocation. Remember this. Reaction goes via formation of the carbocation. You take this tertiary alcohol, you take this tertiary alcohol, before we get a final product, before Cl is being getting this substituted, what will be the thing? The H plus is there. This H plus is from HCl, right? This H plus is from HCl. If you are doing a reaction with a H, what did I write? Yeah, HCl, from HCl, right? So what happens is that this is the electron rich. This is the electron rich. It will attack electron deficient part. So this is called as protonation of alcohol. This step is called as a protonation of the alcohol. From here to here, I write over here. This is called as protonation of alcohol. So what you get is this CH3, CH3, CH3. This is O, H, H, and the positive charge. Later, this bond breaks. This is the bond which breaks, and what you get is a tertiary carbocation and water. Tertiary carbocation and water. This is what you are going to get. Tertiary carbocation and water. So Cl minus, which is there over here, Cl minus is there, which is going to attack on this carbon. That was from that, and that is how you are going to get a halide. That is how you are going to get a RCl over here, final product of the reaction. But why we are getting a turbidity faster? So here we are getting a tertiary carbocation. Remember this, right? But in the case of a secondary alcohol, if it is a secondary alcohol, if it is a secondary alcohol, in the presence of acid, what would be a thing? The thing would have been this way. This will go, and you are going to get a secondary carbocation. Just understand this. You are going to get a secondary carbocation, right? And in the case of primary alcohol, what you are going to get? Let's take this. You're going to get a primary carbocation, right? So later it will be connected. So this is primary carbocation. This is secondary carbocation. So which is more stable carbocation? This. So this carbocation will be formed faster. This carbocation will be formed faster. Next, that Cl minus. Next, Cl minus will attack here, and you will get a corresponding alkyl halide. I'll just write this is little bit congested. This is the alkyl halide you are going to get here. Later, this part. But the thing is that here there is a secondary primary carbocation, here there is secondary. In tertiary alkyl halide, there is tertiary carbocation. That's why tertiary alcohol halide, this reaction is faster and you get a faster turbidity over there. And that is how you can identify which alcohol it is, primary, secondary, or a tertiary alcohol. Next is dehydration of alkene. Your heading is next chemical reaction is dehydration of alkene. So dehydration of this is not dehydration of alkene, dehydration of alcohol. Dehydration of alcohol. Dehydration means what? Dehydration means removal of water. It is removal of water. What is the meaning of this? It is removal of water. So dehydration of the alcohol leads to what? It leads to dehydration of alcohol leads to formation of alkene. Let's take some simple alcohol. Let's take some simple alcohol this way. Let's take some simple alcohol. This is OH and this is CH3, right? Which alkene it's going to give? Let's understand this. You add a acid to this. You add acid to this, right? So by directly I write the mechanism will with mechanism only we'll understand this. So this is a electron rich. It will attack over here. Means that is like a, one of the step we did in a Lucas reagent, protonation of the alcohol. CH3, CH2, CH. This is changing to OH and a H and the positive charge. This is CH3. So this will break the bond this way, right? To give stability to the oxygen. Over here, this bond is breaking to give stability to the oxygen because positive charge on a electronegative element is unstable. Now here, there is a formation of a carbocation like this, right? So there is a carbocation over here. So I'll write this hydrogen this way. I'll write this hydrogen in this manner. This hydrogen over here. And I'll write this hydrogen this way, right? So to give a stability, again there is a carbocation, means it is intermediate, although secondary carbocation, but it is an intermediate, they are always unstable. The bond can break this way to form a double bond, means this positive charge, nullify the positive charge. I will mark this as a path A, and or it is a possible that it will go via B, it can form this way. So here what will happen is that I will write two products. One is one is due to B. One is due to B is this CH3, C double bond H and CH3 plus H plus. This is utilized for dehydration of the other, and this is via B. The compound what you are going to get is this alkene. So this is more stable alkene. This is more stable alkene. This is less stable alkene. Therefore, this is major product. This is major product and this is minor product. The question is, how do we decide the stability of the alkene? How do we decide the stability of the alkene? More the number of the alkyl group, more the number of alkyl group on either side of double bond, more is the stability of alkene. Remember this. More is the stability of alkene. This is the rule. So this alkene is more stable. Why? Because there are two alkyl groups on this. And here there are one alkyl group. That's why this is less stable. So here, dehydration of the alcohol. When it is dehydration of the alcohol, we have to understand that which will dehydrate easily. If you ask whose dehydration, which alcohol will dehydrate, hydrate very easily among tertiary alcohol or secondary alcohol or a primary alcohol. Order is this. Remember, tertiary alcohol will dehydrate very easily. If you see the mechanism, in tertiary alcohol, you get a carbocation. Everywhere there is a, since there is a formation of the carbocation, there is, since there is formation of carbocation, since there is formation of carbocation, tertiary alcohol will give, will give tertiary carbocation. Secondary alcohol will give secondary carbocation and a primary alcohol will give primary carbocation. That's why the order is this, right? So this is the order of the dehydration of the alcohol. Next, we'll move on to the oxidation reaction. So now coming back to the remembering that flow chart which I discussed before. So next is oxidation of alcohol. So if we do the oxidation of the primary alcohol, we get a aldehyde, and if we do the oxidation of the aldehyde, we get a carboxylic acid. So we'll talk about some of the oxidizing agent. Oxidizing agent. If it is a primary alcohol, if it is a primary alcohol, this is a primary alcohol. Okay, and you are using the oxidizing agent. Remember that those reagents were reducing agent. These are the oxidizing agent. What you get is RC double bond HO. Right, this is what the oxidizing agent is. So if this reagent, if this reaction, if it is a primary alcohol, same primary alcohol, and if you are using a strong oxidizing agents like a KMnO4, remember this, KMnO4 is a strong oxidizing agent. Reaction won't stop at a aldehyde, it will change it to a carboxylic acid, right? And if it is a secondary, if it is a secondary alcohol, if it is a secondary alcohol like this, if it is a secondary alcohol, you do the oxidation like CrO3. If you are doing, then what you will get, you are going to get a ketone, right? So here this is aldehyde. On a primary alcohol I have done two reactions, two oxidizing reaction. This is carboxylic acid and this is ketone. Oxidizing agents are CrO3. KMnO4 is the strongest, that's why reaction go up till carboxylic acid. And we can also have one more reagent, that is PCC. There is one more reagent, PCC, which will convert alcohol. What is the meaning of PCC? Like if you take a primary alcohol, We take a primary alcohol this way, R CH2 OH, and I am using the reagent PCC. Now PCC is what? PCC is full form is pyridinium, pyridinium chlorochromate. This is what the PCC is, short form. Oxidizing agent, very good oxidizing agent. It is not going to touch a double bond and all. Nicely, it will do its own job. So this is going to give me a C double bond OH. This is the whole reaction. Means, uh, yeah, this is the whole thing about this reagent. So we have learned about the three reagent. One is PCC, one is CrO3, one is PCC, and other is CrO3, and other is KMNO4, which is a strong oxidizing agent. So this is take this will it will take to a carboxylic acid. These are good oxidizing agent. It will convert it to up till aldehyde. Yes. So I'm ending up this over here, this lecture. See you in the next lecture. Find this lecture interesting, and you can also share this among your friends just so that it helps